Determine whether or not plug holing is likely to occur with a vent located 2 metres from the edge of a reservoir with the following parameters. Your density of ambient air is given as 1.177 kilograms per metre cubed. Acceleration due to gravity is 9.81 metres a second squared. The ambient air temperature is 293 degrees Kelvin. Your theta value, your temperature increase is 120 degrees Kelvin. And the smoke layer depth is 1.5 metres, so it's got a narrow smoke depth. The aerodynamic vent area of each vent is 3.87 metres and the ventilator has a coefficient of 0.6. The temperature of the smoke layer is 413 degrees Kelvin and the smoke leaving each ventilator is 19.5 kilograms a second. Now, as the ventilator is located more than 2 metres away from the edge of the reservoir, this is the formula you should be applying, where mcrit is the maximum amount of smoke that can enter a ventilator without plug holing occurring. Yet rho 0 is your ambient air density. You've got your gravity, 9.81 metres a second. You've got TO, which is your ambient air temperature. Your theta is your increase in temperature of smoke. Your D is your smoke layer depth. TL is the temperature of the smoke layer in metres. WV is the width of a circular ventilator with the same area as any other vent. Because I'm not sure what size vent, what shape you're going to have, you have to convert it to a circular ventilator to make this formula work. So that's what WV is. Now, you've got to determine WV, and this is the formula to apply. WV equals 4 times AV per vent. Now, this is the geometric area. This is once you've taken into account the efficiency of the ventilator, divided by pi, and the whole lot square rooted. That's what you have to use, this formula. Now, when you put the variables in here into this equation, you should have got this. Your WV equals 4 times 3.87, which is your aerodynamic free area. Divide that by your 0.6 to get your geometric area. Divide that by 3.142 and square root it. You should have got a WV of 2.87 metres. Now, you put that into the mcrit formula here, as you can see. You should have got an mcrit of 13.1 kilograms a second. So if more than 13.1 kilograms a second is leaving each ventilator, that is very likely to plug hole. So what will happen is it will induce airing. 13.1 kilograms a second. In this case, the smoke leaving each ventilator is 19.5 kilograms a second. The mcrit is 13.1 kilograms a second, which means in this case, it is likely that plug holing can occur. And what you might need to do is have more vents, smaller. That's how you can solve this problem. Have more vents, but smaller vents.